Hello everybody and welcome to another Blender tutorial. This time we will try to recreate this scales effect in Blender. It's something like Mystique from X-Men, and we will just need an add-on for Blender named Animation Nodes. So go to the description, there is a link to the GitHub page where you can download it, install it, and everything will work. So let's jump right into the Blender and let's start making our scales. First thing we will need is definitely the scale itself. So just add some plane, move it to the x-axis like this, and let's see the shape, how it could look. It's probably the best to put there some image as a reference, but for the purpose of this tutorial we can just eyeball it. Why not? Let's see, this could be good enough. Let's scale this down, and this too with the proportional editing enable. Yeah, but not smooth, but sharp. SY. Well, this kind of works. It's not too bad. Okay, that's our scale. Let's name it. And once it's named, let's see what we will need from this object. It will have one material on one side, other material on other side, and it will flip on this axis to achieve the effect. Also, it would be nice if we could bend it a little bit in the process. So let's go to the modifiers and add a simple deform modifier and set it to bend. Here, if we change the angle, we can see the bending, but it's in the wrong axis. Usually, we would put here another object that will define another set of axes that will fix this problem. But I want to replicate this scale many times on some other object, and if I would have another object as axis, I would need duplicate this another object as well, and I don't want that. So it's easier to just adjust the rotation in the edit mode of the scale itself. So just rotate it around X in 90 degrees and turn off the proportional editing, of course. Now we can see it's on its side, but it's not that much of a problem, but the deformator, the modifier, works as expected. Okay, then how we could change the materials? We can set it along the normals, so one side will be one material, other side will be other material. But even for the visuals will be better if the scale will have some thickness. So let's solve all these problems with a solidify modifier. And we want the solidify not be just to one side. So offset set to 0. You can see now it's on the both sides. Something small, like in 8 centimeters. Why not? Even thickness, it doesn't change much. And we can change materials here on the generated faces. So if we go to the material tabs and generate 3 slots for materials, we can have first as, for example, the red one. There will be something in the middle that will change as time will go, you will see. But for now, it's just a rim material. Where am I putting it? Here. Rim mat. Why not? And there will be the other side. The third will be green. I should learn how to write. Okay, let's see some settings for the viewport so we see where the materials actually are. So this is green. This will be, for example, blue to see where the rim material actually is. And some red material for the other side. You can see this is red right now. The whole thing is red. But if we go back to the modifiers, we can set the material for the other face. That could be the second one. So this is 0, 1 and 2. So the green will be the other face and the rim will be the middle one. So now you can see that one face is green, the rim is blue and the original face is red. Okay, that doesn't seem too bad. So we will have always green here, always red there, and the rim color we will change gradually from red to green as we will need. And then of course some subdivision surface just for good measure. Okay, that could be all we need. Let's see the bending, it will work. And we will need this duplicate to some object. So let's jump to some another layer and create object that will be base for our scales. For example, this rounded cube, I like this topology, so I will use it. For the nice pattern on the scales, we will place them on the vertices of the object. So it's good to have quads only objects, because you will get these 4 scales here, and we will get the vertex in the middle of each face with just one simple operation. Go to edit mode, select all, and use poke faces. You can find it here if you type poke. Here it is. Poke faces is Alt P. So if you press Alt P, it will subdivide your mesh the way that in each center of each face is a new vertex. But well, now it's not really a sphere. Those points should be further from the center. So let's spherify it again. So select all and go back in here and find to sphere. Here it is, Shift Alt S, and set it to 1. Okay, now it's perfect sphere and perfect topology for our scales. It should work on any quads only object. You will have quads only, you will poke the faces, and you will get this kind of pattern for your scales. Okay, this will be our base mesh. And other thing is some control over the scales itself. So where it's green, where it's red, where it's already turned off, on and off. So I will use some empty object. The shape could be sphere, so I can see the influence, how far it is. And this influence also how it will be named, like switch, for example. And another thing, the influence shouldn't start and end just in one place. So the rotation of the scales should be gradual from one side to another side, not just flipping in one frame quickly. So let's set something to control this gradient again. For example, another empty. I'll just duplicate this, set it to blend or gradient or something, parent it to switch. So the switch is parent of this blend, and the blend will be somehow bigger. So the scales will gradually rotate from this point to the end of the other empty, and they are moving together, of course. Well, this should be pretty much set up. Now we have to go to the animation nodes itself. So let's jump to the node editor. Let's go to the animation nodes, create new node tree. We will not want to run it always, just when something is changed. And we will create also a new trigger when the switch moves or scales. So new trigger will be monitor property on object. Okay, the object will be the switch and the property will be location. Okay, so when I am changing the location of the switch, this node tree will run as well. And also the changing the scale, another trigger, the same switch, location, scale. Okay, and we need the scale of the blend as well. So another trigger, the blend and scale. Okay, we are set up. So first thing first, we need to get all these vertices, so we know where to place all our scales. So let's find out object and where it is. No object mesh data. Yes, here it is. And we have here already the vertex locations, but we don't want only the locations, we want the normals as well, so we will use the vertices itself. So here, use world space and set it to the base. So now we have all the vertices of the base. Okay, now we have to duplicate our scales. So object instancer, and it will create instances of our scales. Copy full object, so we have also all the modifiers on the scale itself. And how many instances? It depends on how many vertices are there. So we need list get length, and we set there list of all vertices and put the length here. So we have now as many scales, not now, we will have to set this scale. So now we have as many scales as there are vertices on the object. Okay, now we want to place them on the vertices. So let's create some loop, and for better layout, let's put one frame to actually the node tree that runs, and another frame for our loop that will run for each scale generated. So here subprograms loop, name it like scales, why not? And what we will need, the objects itself, of course. So object list, those are our scales. We will need the vertices, so vertex list, and we will need something to change, scale, but not scale as scale, but scale as dimension. So add a parameter float, and it will be dimension, and this is probably good for now. Let's see what we will need later and add it later. So for now we will just transform output and put there our scales, and first we will change their locations. So check these three, we will change the location to position of the vertex. So we have to find out the position of this vertex, where it is, mesh vertex info. So now we plug this vertex here, and we know the location, normal, and all the group weights if it's useful. It could be for the dynamic paint, for example, to paint the influence on the scales. But now we will just choose the location and place all the scales on its position. It doesn't do anything right now because we are not using this loop. Let's put it here, scales, and this loop will use our scales. We have them there, and all the vertices, they are there. Okay, they are placed as pretty much we would expect. But we want to change the dimension, the scale of the scales. Okay, let's change the scale. How much it will be the dimension, put it here. Animation nodes created for us this vector from values, so the scale is all values of this vector are the same value as the dimension. Let's clean it up a little bit. And one thing we can do is put there a number float as input, name it somehow. Here label, for example, scale. I know it's confusing a little bit. And put this input to the dimension. And we will do it because if we have input node, we can go here to advanced settings and show it in viewport. So that means that if you go here in the tab for animation nodes, there it is, then there is data input. And we don't have to be in the node editor, where it is, data input, animation nodes, and we can change the scale in the editor. So we will manipulate with our data, our scales here and not in this weird view. Okay, that's one thing. We have the scale. Well, now we need to change the rotation, of course. So let's check the rotation and how we will change it. First, we will manipulate it the way that all the scales will look the same direction as the normal of the vertex. So let's put there rotation, direction to rotation. This could be used. No, not like that. Vector. Where was it? Rotation, direction to rotation. And direction will be our normal. And it should be, if I recall correctly, the x or minus x of the scale should face the normal, and the z of the scale should face the global z axis. Okay, let's try it. This looks pretty much okay. Let's try if y will be good. This seems to look good, but I am pretty sure this will not work as expected. Let's try. Continue with these settings. And probably we will remap it that way. Because we want to change this rotation according to some parameters. So we will use separate and combine Euler. Here it is. Separate and combine all three. Use decrease for both of them. So for now, nothing is happening. We just know the rotation of x, y, and z. And we will manipulate the y-axis. I don't really remember. Let's try it. Number math. Add something to the z. Let's see. That's the wrong axis. So the z we will not manipulate. Let's try y. Yeah, y is the right axis. And as you can see, something doesn't really work. And I am not really sure why, but it has pretty easy fix. Let's just use this method that we used before and rotate them right here to 90 degrees. And now, magically, everything works as expected. So we will just need to adjust this value from minus 90 degrees, which is pure green, to 90 degrees, which is pure red. Okay, the scale is little off. Let's set it a little bit bigger. So how we will manipulate this value? and it should be dependent on the distance of this scale from our switch. So if we move the switch closer, it will hit some threshold between the switch and blend, and between these two values, this B value, this 90 degrees, will change to minus 90 degrees, or the other way around. It doesn't really matter. So we need the distance. Where we can get it? We need position of the switch object. So let's get it somewhere. So we will need some vector. Vector switch, for example. And let's put it here. The switch position is object transform. Input, the object is switch, and the location of the switch is our vector that we need. Okay, now we have the location of our switch, and here you can remember that we have location of our scale. So if we find their vector distance, we can find distance from the scale to the switch and remap this distance to values from minus 90 degrees to 90 degrees. So where it is, number, map range. So what is the value? Value is the distance. So distance from the switch to the scale. Okay, we will use the interpolation, probably just linear, but I want to just show you what effect it has. Input minimal will be 1, which is the border of the switch. Or will it? We want to scale the switch. Yes? So this won't be just 1, it will be the scale of the switch. So let's put it there. New parameter, the scale of the switch. It will be float. Float, and it will be switch scale. And the other value will be scale of the blend, of course, the maximum. So another float, and it will be blend scale. Okay, let's see where we can get those values. The scale of the switch is right here, so just plug it there. It will separate the scales. They are uniform, so if one of them is 1, all 3 of them are 1. So we need just X value. And the scale of the blend is another transform input. Not switch, but blend. And the blend scale. So put it there. Move the separate vector here again. And I hope it's pretty much all the inputs we will need, because it starts to get a little clustered. But all should work as expected. So back to our giant loop. We have the scale of the switch, so it will be the minimum input value, and the scale of the blend will be maximum of the input value. So if the switch now is 1, 1, 1 and we are taking the X, so the minimum value is 1 and the maximum value is 1.62, could be 1.6 for all of them, but we are reading just the X. So keep it in mind, if we scale this in the Z, nothing will happen with our scales. Okay, and to what range we are remapping it? Well, to minus 90 to 90. And let's plug it there. And as we can see already, it starts working. Wow. So when we are further away than the blend scale, the value is 90, so everything is red. But if the scale moves between blend and switch, so it's between values of input min and input max, so it's somewhere between, so it means it's somewhere between minus 90 and 90, the rotation. And when it's inside of the switch, so the value is less than 1, the distance is less than 1, it means it's minus 90, so it's all green. So it not only works with the movement of the switch, but also with scaling. But somehow, weirdly, somewhere is something wrong. Some math doesn't add up as it should. Well, this is a little bit unexpected. Well, I think it has to do something with these directions, but I really don't know for now. And to be really honest with you, I don't really care for now, because at least the position works, and let's work with that and move on, so we will not lose any time to finding those little mistakes. You can tweak it in your free time as you want. The only thing we want is the bending of the scales. So the same principle, we will take the distance, remap this value to some values for bending, and put them to the modifier of the simple deform modifier here to the angle. Okay, where we can get this value? Here, object and data path output or attribute output. It gets pretty much the same result. Well, this is kind of weird, so let's use the attribute output. And the object is our scale. So where is the scale? You can put it right here. Or no, not like this. It would be probably better to do it after the deformation. So attribute output. Let's reconnect the scale to the transforms, and let's change it after the transforms are done. Okay, the data path here, just right clicked and where it is, copy data path. Let's paste it here with Ctrl V. Value has wrong type. That's because there is no value. And we want some angle from, let's see, minus 45 or 45 to minus 45. Let's see if it will work. So map range, distance, and from the same thing here we can use reroute for input min, because it will be the same, and again reroute for input max, because it will be again the same, but this will be from minus 45 to 45. But this interpolation will not be just linear from this value to this value. This interpolation will be different, because if I plug it there, first of all, the values are really off. Here you can see it should be something like 45 degrees, but it's 1000 and something. and that's because it takes the value 45 and think it's radians, so it converts it to the degrees. So let's do it here. Radians to degree. No, the wrong way. Degrees to radians. Okay, that's better. And let's see what we can do with the interpolation. Let's make some. So interpolation from curve mapping. Yes, here it is. So the interpolation will not be just from minus 45 to 45, but it will be from 0 to minus 45, and in the middle it should be back again at 0, and in the end again 0. So let's try if everything works. It's, as I see, the different way. That's because the angle from the blend to the switch, same as was the rotation, should not go just from one bending to the opposite bending. It should go from no bending to full bend to one direction, back to no bending where it's just in the middle, and again to full bending to the opposite direction, and no bending at all when it's done, when it's after. So it's this simple curve, just a different way around. Let's see. Well, here you see the bending. It's pretty abrupt, as you can see. So let's change these values from minus 30 to 30. Okay, that's kind of better. And this interpolation for the rotation itself could be something different than linear 2. Let's see what there are some presets. For example, the back. That even means that for a few moments it will be on the opposite side, so it will be under minus 90 and over plus 90 degrees. So it's really weird effect. Let's see sinusoidal. It kind of evens everything out, so it's ease out and ease in, and this looks pretty much the best for me, and I think I would keep it as it is. Yes, that's pretty much works the best. Let's see the scaling, if there is still the same problem. It seems like the bending doesn't really scale. Oh, yes, I get the problem now. So I hope you didn't lost your patience. The blend scale doesn't change because it's parented to the switch. So it means if the switch has scale 2, for example, it's almost 2, the blend didn't change at all. So we have to always multiply the blend scale with the switch scale because they are parented together. We can multiply it right here, number, where it is, math. Everything that you are doing right here is happening just once when it's calculated, but if we would multiply it right here, it wouldn't really slow down, but it would unnecessarily multiply it for every scale in the scene. So just multiply these values together, and now finally it works as expected. Okay. So we can go back there, set just some transform logs, so this shouldn't ever rotate and the bend shouldn't change location or rotation. Well, what we need to do now is just a render, because everything else is prepared. So let's jump back to the node editor and create some materials. But before that, create camera. Let's set some angle. Here, rendered view. What we need is some lighting in the world. As always, I really don't want to spend too much time in this lighting. So where it is, converter math here, multiply twice, non-color data, and pick some HDR texture. For example, right here. Why not? Well, that's weird. Let's pick something else like this. Kind of better, but dark. Something lighter, like this one. Well, this is probably too much, but whatever, it could work. Let's jump to the materials. First, the simple ones. One simple material is the red. Here you can see. Red could be just a diffuse, why not, but I like to use the dielectric. If you are using later versions of the Blender, you probably will use principled shader. So this is red, letter rough. Ctrl C to get this node and jump to the green. Ctrl V and change this color to the green. And now the rim material, because this should be the same shader, but it should change color the same way the scales change rotation. So based on the distance from the switch object. And we for it need to use the coordinates of the switch object. So we need both of the colors first. So let's put there color mix RGB, and this will be the one color, and the second will be from the green. So Ctrl C, Ctrl V, and we won't change these colors based on the distance. So once it's the green, once it's red. Where is the position of the switch? Here, input texture coordinates from object switch. Where it is? Here. And if we see the object value, you can't really see anything, but you will have to believe me that there is vector that it's exactly distance from the switch, but it's still a vector, it's still a position. We need to get the size of that vector, the distance itself. I have prepared this magnitude for getting the distance from the object. If we jump inside, it's just a simple Pythagorean theorem. I separate the vector, put everything to the power of 2, add everything together, and make root of that value with the power of half. And that's all. So I get the distance from a switch. Okay, I can move the distance 1 unit from the switch, so we start at 1, not at 0. It's the same for the rotations. They are start at 1, not at 0. So where it is, converter, math. Okay. So subtract 1. So the 0 is still on the beginning of the rotation. So here it's still just a green. And now we will put there just a color ramp to manipulate this value. Let's see how it will work. Let's plug it there. I will need to switch these values. So like this. Plug this to the factor. And let's see. Well, if it's close to the switch, it's still green, as it should be. The lighting is really too much. So it's green if it's close to the switch. If it's further from the switch, it's red. And if it's somewhere in the middle, it's somewhere in the middle of those two colors. And the good thing about this material is we can use it in the base mesh as well, because now you can see the white color beneath the scales. But if we use the rim material in the base mesh as well, well, even if there are no scales, we see the gradient from the switch. Let's select the switch. Let's see in the 3D view where the switch actually is. And let's move it. And you can see in the right as the colors are changing. Well, and that's pretty much it. At least for this tutorial. You can just animate the switch, you can animate the base mesh, and you can just switch this base mesh with whatever object you want. For example, our denser, and try what it will look like. Okay, well, this tutorial is definitely longer than I expected, but I hope you find it at least a little bit useful, interesting, whatever. I thank you very much for watching, and till the next time, bye.